Good morning, ladies and gentlemen. I am here on Thursday, April 30th. The days kind of blend together during this remote learning. And I just got done grading all of the carbon cycle labs that came in. And for the most part, they were pretty good. But what I wanted to do was go over some important points that some of you might have missed. So you understand what you did wrong and you understand the importance of this moving forward. So what I've got, okay, is here is the carbon cycle lab. Here is the master copy. I made a copy for myself. And what I did was, here are the first three questions that you had to answer, all right? And these were reading comprehension questions. I asked you to read this kind of dense textbook style passage here. And the answers to those three questions were right in that passage. Number one, does the amount of carbon in our Earth's environment ever change? The amount of carbon in this system does not change. Number two, three ways carbon can be released. Organisms die and decompose, plants respire, volcanoes erupt, wildfires blaze, and geysers erupt. There's your three. And then lastly, what do humans do? Burn fossil fuels and land development, deforestation. So these 3 points, I'll be honest, were kind of gimmies. It was right here in the reading. Moving down, here is the lab. Here's an explanation of the lab. There was a video that Chloe made that also explained the lab. And here was the data table that you had to kind of figure out. And this data table, I admit, was a little bit wonky. It wasn't in total order. What we had to do for the first 5 rows was keep deforestation the same and change the amount of fossil fuels. And then for the last 5 rows, we had to keep fossil fuels the same and change the amount of deforestation. Remember, as we said up here, okay, a negative deforestation rate means we're actually planting trees. So right here with this deforestation rate of -4, that means we're adding trees to the environment or adding grasses or adding some type of plant that can suck carbon out of the air. What I did was when I filled out this data table, I kind of reworked it a little bit. I didn't make you do this, but this made it easier for me to see. Here it is, this top data table right up here. This is when we kept deforestation the same, and we went from decreasing our fossil fuel usage to increasing it by 4 times. And then this data table, it's the same numbers, but it was when we added trees at a rate of 4 times to get rid of trees at a rate of 4 times, okay? Now, the actual numbers are really tricky to get, okay? The actual numbers are kind of hard to see because you've got this light gray line, the orange goal limit line, the black projected line, and they all kind of meet up. So the specific numbers are not what I'm really looking for. What I'm really looking for are the trends. Here are my trends for fossil fuels. Notice that when we increase our fossil fuel usage, we come and get closer and closer to present day of reaching the goal limit. The amount doesn't really change that much, but our trend line decrease certainly does. And our trend line decrease amount certainly changes a lot. Notice when we play with the deforestation numbers, when we add trees or get rid of trees, these numbers don't, it's like a span of 10 years. These numbers don't change very much. These numbers stay the same. These numbers don't change very much. This goes from 731, more than doubled to 1672. This goes up by 13 parts per million. It's really not a lot. So what I see from this is that fossil fuels is pretty impactful. The numbers change a lot. Deforestation, while it is impactful, the numbers don't change as much. It doesn't make as much of a difference, okay? So once you've gotten through that data table, we get to our questions, okay? We get to the questions. So, number one, where are the largest carbon sinks located? In other words, where did all the gray carbon rectangles end up at the end of the simulations? Now, I said in the video, I want two things in each of these answers. I want details from your data, and I want details from your reading in order to get full credit. I did not see a lot of that. I will be honest. I did not see a lot of data or reading backing up your answers, okay? Just giving me the answer doesn't really make it good enough, to be honest with you. You need to give me reasoning and thought that backs up your answer. The largest carbon sinks are located in the atmosphere and the deep ocean. After we increased the fossil fuel 4 times, the atmosphere had 1153 and the ocean 1786, a 300% increase and an 1800% increase. If we look here, here is a picture where we increase the fossil fuel usage. We increase the fossil fuel usage, all right? And we notice when we increase it by 4 and we increase it by 1, the atmosphere gets 1153. Those are all those gray rectangles. That's a big sink. The ocean gets 1786. That's a big sink. Notice there's nothing left here. And here is my graph. When we increase fossil fuels, it's a very, very steep graph. We see the same thing if we increase our deforestation by 4 times. Okay? It's not as steep as a line, but we get a significant amount, 929, of carbon in the atmosphere, and even more, 2355 in the ocean. Here's a question. Why do we get so much more in the ocean when we cut down the trees than the atmosphere? Maybe I'll ask that question of the students next year. Number 2, why did the trend line start decreasing? Well, the trend line started decreasing because we used up all of the coal and fossil fuels in the ground. The trend line starts decreasing because we don't have any more coal to burn. We don't have any more oil and gas. We have none left. When we have none left, we have none to burn. Therefore, we're not going to put as much in the atmosphere anymore. We're not going to put as much in the atmosphere anymore. We've just run out. Hopefully we have solar-powered cars by then. Number 3, this was the most important question. Which factors seem to be more impactful, fossil or deforestation? The answer, quite straightforward, is fossil fuels. If you look at the graphs, if we increase fossil fuel, we reach our goal limit in 20 years, and we have burned through all our coal in 60 years. If we decrease our fossil fuel usage, if we go to negative fossil fuel usage, -1, we never reach the goal limit. Fossil fuels are so impactful that by decreasing our amount of fossil fuel usage by a factor of just 1, not even 4, by a factor of 1, we will never run out. You can click this forever, and it just keeps going down and down and down and down. We never reach our goal limit, and we never get that trend decreasing. On the other side, if we if we cut down more trees, even by a factor of 4, we still reach those limits, but we reach them later. Increasing deforestation by 4 times, it's rough, but those limits are reached much later. We don't run out of our coal reserves until 100 years from now. It's not good. 100 years from now, it's not great, but it's certainly a lot better than fossil fuels. And the hardest question was number 4. Why? Why do you think the factor you chose is more impactful? Well, if we go back up here, we notice from our reading that when organisms die and decompose, carbon goes into the atmosphere. And when plants respire, like trees, carbon goes into the atmosphere. When trees die and decompose, they add carbon to the atmosphere. Plants respire, that adds carbon to the atmosphere. So adding more trees reduces carbon overall, but not as much as getting rid of gas and coal and oil. Reducing fossil fuel usage only has positive benefits. Keeps carbon in the ground, preventing it from moving into the atmosphere via car exhaust, for example, or moving into the ocean via fertilizer runoff. Again, Background from the reading backs up your answer. Actual data from your simulation backs up your answer. No more coal or oil to burn. We saw that with the great rectangles. Backs up your answer. Specific data, specific numbers from the simulation backs up your answer. That's how you get full credit there. Okay. That is our explanation video for the Carbon Cycle Lab. This is important stuff. This is going to be not assessed via a formal test, but it will be assessed via a formal final. We're going to be rolling out those finals and all that stuff next week. Today, you've got your Earth's climate history questions. That's Thursday. That's going to be due tomorrow, Friday. Also tomorrow, we're going to roll out a big lab on climate change. So be looking for that. Have a wonderful rest of your day, ladies and gentlemen. I hope you get outside. It's going to be gorgeous today. Goodbye.